Hello, this is John Feltz from GenCell, where we believe in power for humanity. Thanks for joining me today for the Sacramento eMobility Hub presentation. Let's dive right into it. The Sacramento Regional Zero Carbon Transportation Initiative has a plan laid out for mobility or eMobility hubs and their resiliency plan. As you can see on Section 3 of the SRZCTI, the plan is to put out 52 total e-mobility hubs. And along with those hubs, they plan to build microgrids for energy storage and microgrid capabilities for charging operations during power outages and in times of critical need. So here's the e-mobility hub resiliency plan that we have come up with at GenCell. So the Regional Air Quality Management District and SMUD and local governments are planning to build 52 of these hubs throughout the Sacramento mega region. The idea is that the mobility hubs will introduce electric vehicles and EV charging to underserved communities for the most part. And then they will provide workforce development and educational opportunities as well in each of these communities. They'll ensure that EV fast charging is available in emergency situations as well as in normal situations. Then it'll also stabilize the electrical grid throughout these neighborhoods where deployed. And we will also develop the microgrids that fulfill the SRZCTI goals while creating job opportunities and provide business continuity in these e-mobility hubs where applicable. So how are we going to fulfill these goals? Well, by building microgrids for EV charging and grid stabilization, the Sacramento Regional Zero Carbon Transportation Initiative can achieve multiple benefits, such as enhancing the integration of renewable energy sources, such as fuel cells and hydrogen, solar, and wind into the grid. Also, by improving reliability and security of the power supply for EV drivers, especially in remote, rural, or underserved areas. Also, we will be increasing the flexibility and efficiency of the grid by allowing microgrids to provide ancillary services to such the buildings for backup when necessary. And we'll also be creating new economic opportunities and jobs for these local communities for maintenance, installation, planning, and construction. So how are we going to add DC fast charging without impacting the grid? That's the big issue right now. Everyone seems to be saying that there's not enough energy, we can't put out EV fast chargers, but it's just simply not the case. There are problems that we're facing, but there are ways around it, and that's what we're here to talk about today. Our solution will provide battery storage with 480 volt three-phase output. It will also act as a battery storage for any solar array that can collect and recycle electrons from the sun while the sun is shining. We can also use our product to smooth out the demand curve, especially when multiple EVs are fast charging. And we'll always have peak power available for firing up 2, 3, 4, 5 fast chargers. The facilities surrounding the EVOX and the mobility hub will be able to draw power from the battery energy storage during high impact events, which will allow places like these mobility centers to have business continuity, to keep the freezers cold, to keep the food from spoiling, and to keep the lights on and the air conditioning and heating on if one of these e-mobility hubs happens to be a heating and cooling community service location. Also, and maybe most importantly to get started, is adding fast charging without impacting the grid, because we can store energy all day and all night by trickle charging the battery energy storage system and feeding it back to the chargers and the microgrid surrounding the facility anytime it is needed. So what are the challenges? Right now, if we want to put in fast charging, you got a 12 to 24, maybe longer wait time for the necessary equipment, the switchgear and transformer for the utilities to provide enough power for EV fast charging. More and more, we're seeing outages due to wildfires and other events, especially here in California. And we want to be able to continue business operations even during these events. So the idea is to be able to operate without the grid when necessary, to keep these very valuable locations open. We've seen that a lot of publicly available chargers aren't really publicly available because they're down quite a bit. And we want to make sure that that doesn't happen at these mobility centers. As we know, the Advanced Clean Fleets regulations are going to require more and more EVs on the road, and they may need more places to charge. And lastly, but certainly not least, the rapidly increasing and fluctuating electric rates make budgeting really unpredictable for locations that operate EV fast chargers. So if you can level out that power curve to get the best price at the best time, that's something that most of these e-mobility centers are really going to benefit from. So let's take a look at, say, a greenfield operation here. Maybe you have a lot in a disadvantaged community or any community really, and you want to put in a mobility center here. How do you get started? Well, what if there's no services on this location? Normally, you'd bring in a diesel generator and operate the trailer and any charging equipment that may be needed or necessary on site. Instead, you can just bring in an EVOX and hydrogen supply to get started with if necessary. If there is some grid connectivity there, we can use that as well. But in some cases, there will be absolutely no power available. So here we go, automatic power on demand. We can put in chargers for the electric tractors and equipment that will be used to build and develop this area. And eventually we can have a trailer on that land and operate the trailer with air conditioning for the construction maintenance. Again, starting from greenfield, you can build a center like this. This may look familiar to people in the community of 41st and Martin Luther King. This is the Community Resource Project Luis Perez Center, which I'll use as an example of where we can use something like an EVOX to build out the EV fast charging microgrid for this mobility center, mobility hub, if you will. So the EVOX goes in out back there behind the building. We can start putting in chargers. Those chargers can run day one off of the EVOX. The EVOX can be connected to the existing grid connectivity and or hydrogen. So day one, EVOX arrives. We can set up EV fast charging in literally a matter of weeks, not even months or years. Adding solar canopies and rooftop to this location will provide plenty of renewable energy to store in the battery energy storage system of the EVOX, and then eventually the utility can bring in the transformer and switchgear needed to run this location, if that even needs to be done. Because with the EVOX in place, it might not ever need to be done. But let's say that we wait for a few years and the switchgear gets there. We can swap over, run the whole mobility center on just the transformer, and you could move the EVOX to the next location and go back to step one for the next mobility center and build on that way. So an example of where we've actually done this is at the California Mobility Center in Depot Park in Sacramento. We had the good fortune to have a 6-month trial period here, and so we have brought in an EVOX and we've prettied it up a little to make it look less like a trailer just parked there. And I will throw out some shout outs to Air Quality Management District and Clean Cities for being so supportive during the last couple of years. and then we can throw up fast chargers, which are actually up and running at the eMobility Center right now. So that's the rapid deployment version of this model. That's great for a start. It's great for showing. We've been very successful having events at the CMC and showing off the EVOX and its operating capabilities here with the DC fast chargers. But what about a more permanent solution? This is our next step that we're working on currently. Depending on which funds become available and which grants that we can get, this is our plan. Moving the EVOX to a more permanent location, more out of the way to give back some parking spaces. Adding solar to the rooftop. It doesn't have to be actual rooftop. It can be on top of the EVOX itself. But adding solar will allow for some renewable energy to go in to the already grid-connected EVOX. And then we can put out, we're going to say 4 DC fast chargers. With 350 kilowatts of power coming out of the EVOX, we could run 4 62 kilowatt fast chargers at the same time. They could be 150 kilowatt fast chargers, which will run at 150 kilowatt until the third one comes into use, and then it will drop down and split that 350 kilowatts throughout all 3 of those, and eventually 4. In the Depot Park area, this could be used as public charging capabilities for the fleets that do exist already in Depot Park. Allowing for fast charging to be available at Depot Park will encourage the fleets that are already there to go ahead and start electrifying their fleets, as they are going to be required to by the ACF. So now you've seen the use cases for the EVOX for rapid deployment. I want to talk quickly about what the GenCell EVOX really is. And what it is a combination of BESS, or battery energy storage, and grid connectivity, also solar connectivity, and it comes with built-in fuel cells. The fuel cells are upgradable, so as time goes on and we get bigger and better, more powerful, faster fuel cells that are more efficient, we can swap those out as well. We can also swap out the batteries and make for a bigger BESS. But for now, this is more than enough for, I'd say, a good 4 chargers, up to 7 DC fast chargers that would each operate at that level of 50 kilowatt. But a single fast charger could also be up to 350 kilowatts if you had to charge, let's say, big rigs, because 350 is quite a bit of power. The hydrogen fuel cells in the EVOX are there for what reason? Well, battery energy storage systems are a bit expensive. They're also, space expensive. So keep in mind that the more battery you need, the more space you're going to take up, the more heating and cooling you're going to have to do with those batteries. So if you right-size the batteries for your solution and add a fuel cell, you will have enough to charge, say, 90%, 95% of your your experiences here. So every once in a while, you may need more power, and that's where the fuel cell comes in. The fuel cells can add additional power through hydrogen and the fuel cell process. So you can design your microgrid with a smaller battery component and a larger and a smaller footprint with a larger total power output, because the hydrogen can be delivered time and time again. With the trailer you saw in the previous slide, you would have a couple megawatts of power available, which would run a building like the CMC for weeks on end. And then when you run out of hydrogen, you will automatically be notified when you're getting low, and you can refill that trailer or bring in a new trailer or new package drop-offs like this 12-pack here. A little bit about how it works. There's hydrogen storage outside of the EVOX. There's a fuel cell system in the EVOX, and there is a lithium iron phosphate, DESS, inside the EVOX, which goes through the power control systems and the distribution panels out to DC fast chargers, also out to the building if necessary, if you want to use the EVOX as a building backup, which I would highly suggest in most cases. And then on the input side, we have hydrogen, of course, grid input, and solar input. So all of those different inputs can store energy in the batteries, which act as a backup for the EV fast charging as well as for the building. And as we discussed earlier, this also helps smooth out the power curve for the entire operation. So it can not only benefit for EV charging, have less impact on the grid, but can also lower your overall energy bills by using solar power first, using grid power second, but storing that grid power at the most opportune time of day for cost-wise. And to cap this off, we do have an energy management system we call GenCell Energy Management System, or GEMS, and that does all the alerting, the notifications, the preemptive maintenance, the fuel level tracking and notification. Plus, it gives you the accessibility remotely to your systems. So let's say that in the future there are 52 eMobility hubs, each with an EVOX. Now you have 52 distributed energy resources throughout the Sacramento area that can all help stabilize the grid in times of outages. But first off, keep the eMobility hubs up and operating so that if, say, an emergency vehicle that is electric needs to be recharged, that energy is there waiting to be used. And the EMS can lock down certain applications in times of emergency or crisis so that only specific vehicles could charge or no vehicles could charge, so that we keep the building running, keep the grocery stores open, keep the banks open. That's the whole idea of having that backup battery energy storage plus on-site power generation, along with the solar, but also the fuel cells. So hopefully that was informative enough, and I am happy to answer questions. John F. at GenCellEnergy.com. Thank you very much for your time. Have a great day.